Hello everyone, welcome back to lesson 1-3, measuring angles. Obviously today we're going to be talking about angles, but you'll see that a lot of the stuff we're talking about today is pretty similar to what we talked about in the last lesson when we were talking about measuring segments. So to get us started, an angle is a figure formed by two rays. So if you look at this picture down to the left, we have ray RS and RT that connect at R. They're not opposite rays, they are just rays starting at the same exact vertex. So there are two rays that start at the same vertex. The vertex here is called R, and that vertex is going to be really useful in naming the angle because an angle can be named by either just its vertex. So as you can see here, I have angle names. The first one is just angle R, so I can name it using just the vertex, or I can name it using the three letters that make up the entire angle, as long as the vertex angle is in the middle of the name. So I have S to R to T, SRT, or T to R to S, TRS. Or the other way it can be named is using a number. Sometimes you'll see, especially if there's a lot of angles in a picture, sometimes you'll see them named on the interior with a number. And the only other thing to say in this case, which is actually right here, you cannot name an angle just by its vertex if the vertex is the vertex for more than one angle. So that's the case. Let's say we have this, we have this angle SRT, but let's say I also drew this ray to Q, then I couldn't name this angle just angle R, because you wouldn't know if I'm talking about SRT, TRQ, or SRQ. Those are all options for angle R. So as soon as a vertex creates more than one angle, you should not be naming it using just the vertex. I mean, my rule of thumb usually is just name the angle using three letters. It just makes your life a lot easier. You don't have to think as much when you do that. All right, and then the only other thing here is the set of all points between the sides of the angle. Between the rays of the angle, I would say, is the interior. So anything between the two rays is called the interior of the angle, whereas anything outside the two rays is called the exterior of the angle. Okay, so just a quick example about naming angles. A surveyor, that's someone who surveys land to figure out specific zoning laws, recorded the angles formed by a transit, point A, and three distance points, B, C, and D. Name three of these angles. So, basically what this means is I'm starting at point A, and I'm using my survey equipment to figure out how far away point B is, point C, and point D. And I actually want to get the angles between those because that's going to help me to actually determine the distances between those points themselves. So I'm going to just draw a line through from A to B, A to C, A to D. And as you can see, in all of these angles, we have a vertex at A, but I cannot call any of these angles A, because as we just discussed, when there's more than one angle coming from it, if I just say angle A, I don't know if I'm talking about BAC, BAD, CAD, so it's going to make more sense to actually name them the way I just said them, where I can say, all right, well, I have angle BAC, so that starts at B, goes to A, then goes back up to C. And like I said before, just make sure that vertex is always in the middle of the name. So angle BAC, I also have angle BAD. That's the larger angle, or the largest angle in this point. So I'm going from B to A to D. And then the last one is going to be angle CAD. So that's going to start at C, go to A, go over to D. Now we're going to talk about the measure of an angle. A measure of an angle is typically given in degrees at this level of mathematics. When you get to higher mathematics, it might be given in radians, but that's something for a later date. Since there are 360 degrees in a circle, 1 degree is 1 360th of a circle. When you use a protractor to measure angles, you're applying the following postulate. Postulate 131, protractor postulate. What this postulate says is that if I'm given AB, or line AB, right, because we have that symbol, line AB, and point O on AB. So here we see we have this line AB and a point O. In this case, it looks like it's directly in the middle. It doesn't have to be directly in the middle. Any ray, so as you can see, I have OD and OC. Any other ray besides the rays that are already formed by the line can be given a degree measurement between 0 and 180. I know I said just a couple minutes ago that there's 360 degrees in a circle, but as you can see, the protractor is really just a semicircle, so we're going to cut that in half and go from 0 to 180. You can use the protractor postulate to help you classify angles by their measure. The measure of an angle is the absolute value of the difference of the real numbers that the rays correspond with on the protractor. So, OC corresponds with C, and OD corresponds with D. So if we took the measure given from the protractor of C and the measure given from the protractor at D and subtracted them, and then took the absolute value, depending on which way we subtracted them, that would tell us the measure of angle DOC. And I'm sure you guys have heard these terms before: acute angle, right angle, obtuse angle, straight angle. And basically they're used to classify what types of angles. So when I'm talking about an acute angle has a measure that's greater than 0 but less than 90. So that's going to be a smaller angle. A right angle has an exact measure of 90, and typically you're going to see this little box in the angle. If you do not see this box, you are not allowed in any circumstances to just think that something's a 90-degree angle based on the way it looks. You have to have this symbol, or you have to be told that it's 90 degrees or a right angle. If you do not see the symbol, but you see an angle that looks like this, you're not allowed to just assume it's a right angle. Then we have obtuse angles. That are those angles are going to be greater than 90 degrees, but still less than 180 degrees. So those are a little bigger. They're definitely bigger than our acute and right, but they're not going to go to the point where it's a direct line. If it's a direct line, that is going to be a straight angle, because that is going to measure exactly 180 degrees. Okay, so to get a little practice with both the things we just learned, we are going to use the protractor picture to measure these angles and then classify them as either acute, right, or obtuse. So the first example is telling me to find angle WXV, or the measure of WXV. So WXV is this angle, and this is actually an easy one to do, because as soon as I have an angle where one of the rays is directly in line with the protractor, really all I have to do is now go and read just the one number, and I don't really need to subtract, because this XV really, because it's in line with the protractor, that means it's at degree 0. So now when I go look at angle W, it actually gives me two numbers. It either gives me 30 or 150. Well, looking at this angle, this is an acute angle, right? This is a smaller angle. So would 150 make any sense? No. So I am going to say that this is angle, the measure of this angle is 30 degrees. Now the next one they asked me to look at is ZXW. So that's starting at Z, going to X, and going to W. Well, I'm going to read this, kind of how it's given. So I'm going to start at Z. And again, we get the two numbers. We get 50 or 130. Now, since I'm starting at Z, I'm going to use the lower number, which in this case is the top number. So when I get over to W, because I'm starting with this top number, I should still be using the top number when I get to W. So here I'm going to start with Z at 50. I'm going to go over to W. And again, I'm using the top number here, which is going to be 150. So according to my protractor postulate, I should just subtract the two angles, 150 degrees minus 50 degrees, take the absolute value, and my answer is 100 degrees. Now, I did forget a piece of the actual problem, which said then classify. So the first one is 30 degrees. That's an acute angle, right? Acute is between 0 and 90. Number 3, I got 100 degrees. 100 degrees is greater than 90, so that's going to be obtuse. Now for the next 3, I'm not going to go through the whole thing, but I'd like you guys to pause the video, try them on your own, and when you unpause, I'll have the answers for you. Alright, here are the answers. Number 4 is 40 degrees, which is less than 90, so that's acute. Number 5 is 125 degrees, which is greater than 90, so that's obtuse. Number 6 is 105 degrees, which is also greater than 90, so that is also going to be obtuse. Now, if you did not get these and you still don't understand what you did wrong, just make a note of it so that when we go over all these practices in class, you can ask me about it. Alright, so these two concepts should sound very familiar because we kind of went over this with segments in the last lesson. So the first concept is congruent angles. Congruent angles are angles that have the exact same measure. In the diagram, the measure of angle ABC, so this angle, is equal to the measure of angle DEF. So if their measures are equal, I can say angle ABC is congruent to angle DEF, right? So just like how congruent segments had tick marks, congruent angles have arc marks. So instead of drawing, like a little line through one of the rays, we actually put a little arc in between the angles to show that they're congruent. Now, if I had two other angles, so let's say I had angle, I'm going to call this XYZ, and I had angle, let's just call this one TUV. If I had these angles and they were congruent to each other, but not congruent to ABC and DEF, I would have to use a different arc mark. So I wouldn't just be able to put this one arc, because that would claim that this angle XYZ is congruent to ABC, but it's not. So I would actually wind up putting maybe two arcs. And I put two arcs in TUV. Now the fact that these both have two arcs is going to show that they're congruent to each other, but not congruent to the two angles that have one mark. Now, the next postulate, which again, this is going to sound very familiar, postulate 1-3-2 says, is angle addition postulate. And basically it says, if I have some ray on the interior of an angle, and I know the measures of the angles that connect to that ray, I can add those together, and it should tell me the angle of the entire angle. So I know I just said the word angle and ray a lot, and that's a little confusing, but basically all it says is we can add up two angles that add up to a bigger angle to figure out the measure of that bigger angle. So let's do two examples using this angle addition postulate. So this first example tells me that DEG, angle DEG, which is actually this entire angle, is 115 degrees, and it tells me angle DEF, which is just this part of the angle, is 48 degrees. So what we just learned with angle addition postulate is that if I know, this angle and this angle, I can add them up to the total angle. In this scenario, I know the total angle and one of the pieces, and I want the other piece. So I'm just going to set up that equation and say, all right, well, I know one of the pieces is 48. I do not know the other piece, FEG, but I know that the total is 115. So if I'm trying to solve what FEG is, a little bit of algebra, I'm just going to subtract 48 to solve for FEG. So what I get is that the measure of angle FEG is equal to 67 degrees. Now the next question, I'm going to have you guys, again, pause the video, try it out, and I'll have a detailed solution when you come back. Alright, here's the solution to number 8. This one was very similar to the last one where they told us XWZ, which is the entire angle. They told us the entire angle is 121 degrees. Then they gave us one part, XWY, as 59 degrees, and I needed to figure out the other part, YWZ. So I say, all right, well, the first part is 59 degrees. I want to figure out the second measure, and I know that they have to equal 121, so I subtract 59, and that tells me that the measure of angle YWZ is 62 degrees. All right, so now the last thing we need to talk about in terms of angles is very similar to the last thing we talked about in terms of segments in the last lesson, is the bisector. An angle bisector is a ray that divides the angle into two congruent angles. So when you think of bisector, you think of cuts it in half. So if ray JK is the bisector of LJM, that tells me that these two angles, LJK and MJK, are going to be the exact same measure. So to highlight this, let's look at this example. They tell us KM bisects JKL. So before I even move on to read the rest of it, I'm going to put in my tick marks and say, all right, well, JKM and MKL are the exact same measure. They then tell us JKM equals 4x plus 6 and MKL equals 7x minus 12. Well, if I know those are the exact same measure, I can immediately say, well, I know 4x plus 6, which is the expression that represents JKM, has to be equal to the expression that represents MKL, 7x minus 12. And now I just need to do a little bit of algebra. I'm going to get my x's to one side by subtracting 4x. And if I'm moving my x's to the right, I'm going to move my numbers to the left. So I'm going to add 12 to the left to cancel that 12 out. I get 18 equals 3x. I don't want 3x, I want x, so I'm going to divide both sides by 3 to get rid of that 3, and I get x equals 6. Now the question didn't tell me to solve for x, it told me to find the measurement of JKM. Well, once I know x equals 6, I can then go and plug 6 in to the expression. So 4 times 6 is 24. 24 plus 6 is 30. So the measure of angle JKM equals 30. And then if I just want to double check myself, the measure of MKL should also equal 30, right? Because JKM and MKL should be equal due to the fact that KM is a bisector. So if I really want, I could take this 6, also plug it into MKL. I get 7 times 6 is 42. 42 minus 12 is also 30. So I know I got the question correct. Alright, the next example problem is a little different. So they tell us QS bisects PQR. So before I even read any more, I'm just going to draw that picture. So I'm going to say, alright, well, I have angle PQR, PQR, and I have a ray called QS that bisects it. So that's going to tell me that PQS is congruent to SQR. However, they then tell me that the measure of PQS is represented by 5y minus 1. So that's a good start. But then they don't tell me SQR, they tell me PQR, which is the entire thing. So I can't actually set these equal because according to my diagram that I just drew, they're not equal. However, if QS is a true bisector, that would mean each piece of this is half of the total angle. So I know that PQS is half the size of PQR. So what I can do is I can actually double this measurement, and then it should be the same as that measurement. So I am going to double 5y minus 1. So that's going to be 10y minus 2, right? Because we got to use distribution. 2 times 5y minus 1. I multiply both of the parts by 2. And that should now be equal to 8y plus 12. I'm going to use a little algebra here. Subtract 8y. Add 2. And I wind up with 2y equals 14. So y should equal 7. And the question doesn't ask me what does y equal. It says find the measurement of PQS. So once I know what y is, which is 7, I can now plug it in to solve for PQS. 5 times 7 is 35. 35 minus 1 is 34 degrees. So I know that the measure of angle PQS is 34 degrees. And if you want to double check, you can take that same y value of 7, plug it into PQR, which is double the size. So when you plug that in, you should get 68, which is exactly what you get if you plug it in. So like for the last examples, pause the video, try out number 11, and when you come back, I'll have the solution, and I'll discuss how you get that solution. Okay, so here's our solution to number 11. Number 11 was a little easier than number 10 because after they gave us the bisector, they actually gave us the two angles created by the bisector, and when they do that, we can just set them equal to each other. So we get negative 10x plus 3 equals negative x plus 21. I solve for x by adding 10x to both sides, subtracting 21 from both sides. And what I wind up with is negative 18 equals 9x, which gives me an answer of x equals negative 2. And some people get thrown off by this because they get a negative and they're like, well, I can't have negative angles. And you're right, you can have negative angles. But I am allowed to have a negative solution as long as when I plug it in, I get a positive angle. And when I plug negative 2 into both of these expressions, I do get a positive answer. I get 23 for both of them, which is actually why my answer to the measurement of LJM is 46, because LJM is the entire angle. If half the angle is 23, the entire angle is 46. Okay, so pause the video, try these lesson review problems. When you unpause the video, I will have the solutions here. So go ahead, try these out. Alright, here are the solutions. For the first two problems, pretty easy, just classifying. Now, it's actually easier to figure out number 2 first. They give you WTU and you see the box symbol, so that automatically tells you that this has to be a right angle. And if that's a right angle connected to a straight line, that means this WTS would also be a right angle. XTS is smaller than WTS, which means it's smaller than 90 degrees, so that would make XTS an acute angle. Now that was a question about classifying angles. Next is a question that has to do with angle addition postulate. So it tells us K is on the interior of LMN, but it doesn't say it's a bisector. It's just somewhere on the interior. They tell us LMK, so one of the smaller angles is 52, and then the other smaller angle is KMN, so that's 12. So based on the angle addition postulate, I know that the smaller angles that make up the entire angle should add up to give me the measure of the entire angle. So I really just add 52 and 12, and that tells me LMN is 64. The next question deals with the last topic we talked about, angle bisectors. So they tell us ray BD bisects ABC. They tell us ABD is 1/2 y plus 10. They tell us DBC is y plus 4. Based on this being a bisector, those two angles should be equal to each other. So I set them equal. I solve for y, so I subtract 1/2 y from both sides. I subtract 4 from both sides, and that gives me 6 equals 1/2 y. I don't want 1/2 y, I want the total y, so I multiply both sides by 2, and I get y equals 12. Once I know y equals 12, I can plug it into either of these angles to figure out what half of the angle is, and then multiply it by 2 to figure out the entire angle. So I just picked DBC. I said, all right, well, 12 plus 4 is 16. So if half the angle is 16, the entire angle has to be 32. All right, so make sure you understand everything from this lesson. It's a video, so you can go back and review anything that you didn't understand. And if there's something you still are very confused about, just make sure to make a note of it, and we can always review it during our class time. Thank you. Have a good day.